Today I'm going to introduce to you Dr. Tommy Tafazzoli, Assistant Professor at Washington State University. Tommy has his bachelor's degree in civil engineering, master's in transportation engineering, and is working in the School of Construction, Design, and Management. Uh, Tommy has also LEED accreditation and an E&V accreditation. He is committed to contributing to a new way of teaching construction education, which focuses on decisions and actions for the whole life cycle of projects. So with that, we welcome Dr. Tommy Tafazzoli.
Thank you. Thank you. Thank you for coming. This is the result of a collaborative research of myself and Dr. Ani Jayakaran, who couldn't make it to the conference. So it's not deeply technical, but the good thing is most of us will understand most of the contents since it's not very deep technical. It's actually a review paper that I had in the LID conference last year in Tennessee, Nashville, if any one of you were there, I don't know. So I want to talk about enhancing the functionality of pervious concrete pavements through design and construction. So before we developed the cities, we had this beautiful grass or soil that was capable of infiltrating the water in a safe, natural way. But now it's all, or most of the city surfaces are impervious surfaces on which water just flows and transports oil, sediments, dust, bacteria, heavy metals, pesticides, and all the other, hazardous chemicals to water bodies. So that's a sad thing, right? When this happens, what are some of the negative impacts? So the water quality will be impaired as the first consequence. The fish will be killed, right? So it endangers the aquatic life and demotes biodiversity. Then there will be more charges for the treatment of drinkable water because the polluted runoffs are introduced to that water. And it impacts the health and well-being of communities, and as a result, it promotes immigration of those affected communities. So these are not small impacts. These are actually, some of them could be disastrous. So this shows the necessity of management of urban runoffs. So pervious concrete pavements is a best management practice of controlling runoffs. As you see, they are capable of infiltrating water before it gets a chance to flow to other areas. The difference between them, they have been around since 1970s, as I found in the literature. The most important difference between these pavements and regular concrete pavements is that most of them, for the most part, they are made up coarse aggregates, and there is very low amounts of fine aggregates in them. And the idea is to make a network of interconnected voids that allows the water to infiltrate through the pavement and go to lower levels. So as you see in the picture, they are capable of capturing almost 100% of runoffs, depending on the volume, but we have now very good pavements that could capture almost all of the runoffs. What are some of the advantages of using these pavements? So as you see, this compares a picture with pervious and impervious pavement. The environmental advantages of these pavements is that they control contamination. The recharge of underwater levels will be better with using these pervious pavements. They decrease the need they decrease the need to water for irrigation purposes because the captured water could be used for those purposes. They reduce the heat island effect, something that is not known that much, but they have a positive impact on reducing the heat island effect. And they also eliminate the hydrocarbon pollution that is a consequence of using asphalt pavements. So these were some of the effects in environmental aspect. On the economic side, they lower installation costs, and they allow to use existing sewer systems, so you don't have to rebuild the sewer system to control the amount of runoffs. And in cities where land is expensive, like right here in Seattle, we can benefit from them because you don't need, you don't need like retention ponds or extra land to control the runoffs. And they lower life cycle costs. So economically, they do make sense. So other advantages is that they will reduce the road noise and also road spray, which could be an issue in crowded areas. And also they improve the road safety by increasing the resistance against skidding. So the pervious pavements are not only good for environmental aspects, they also are good considering the economical and other aspects like safety. So why not using them? So major design criteria of them. So if you want to design these pavements, you should pay attention to a few points. Number one, the properties of the anticipated precipitations, like how much rain are you going to receive? What is the length of them? What is the severity of them? These are some of the important factors. The hydrologic properties of the site, like what is the underlying soil, what is the quality of it, what is the connection between pervious and impervious surfaces. That's another design criteria to take into consideration. And the third one is the amount of load which is applied on these pavements, because since they are porous, their compressive strength is relatively lower than regular pavements. So this is something to take into consideration. So in terms of controlling or mitigating the negative impacts of runoffs, we have two different systems, passive and active mitigation systems. But how are they different from one another? The passive system tries to reduce the impervious surfaces in the hosting area, in the site that you are trying to control the runoffs for. In an active mitigation system, you don't only care about your own site, but you also care about the adjacent sites and try to control the runoffs in your site plus the surrounding or the neighboring areas. Obviously, if you want to take active systems, if you want to use active systems, you will need more stringent design measures because you will be hosting more quantity of runoffs, right? That makes sense. And the interesting to know is that regardless of if you are using a passive or an active system, you shouldn't only care about your own site. The amount of impervious surfaces in neighboring areas is going to affect your site because runoff will be transferred from those sites to your site. So that's an important factor to consider. Now, I want to talk about existing issues and potentials for enhancing the functionality of pervious concrete pavements. One issue with them is the infiltration and exfiltration if it's not fast enough. The amount of infiltration you need, or actually the rate of it, the speed of it, depends on the severity of the precipitations, the severity of the rainfalls. So you need to do it, you need to test it with samples before you actually build it. You need to check the infiltration and exfiltration speeds with the samples. This is required. Another issue with them is the clogging of the voids that happen in these pavements. I will explain more about it in a little bit. And also improper slopes. So ideally, the lower or the more gentle is the grading or is the slope, water will have more time to infiltrate, right? While steep slopes will, direct the water to other areas, which is not what we want. Another issue is the disconnection between pervious surfaces due to poor design of the system. So we cannot expect to replace all the impervious surfaces with pervious ones. But you need to make sure about how you connect those two surfaces, okay? The wrong approach to do is to put all the pervious surfaces somewhere and then try to control the runoffs. So one pervious surface should be next to one impervious. I mean, you should distribute the permeable or pervious surfaces between impervious ones. That's the right approach to do. So it's always a combination of both, but they should not, neither of them should be, separate from the other. Or they should not be disconnected. Another big aspect about how pervious concrete pavements function in terms of controlling runoffs is the quality of construction. Poor construction will lead to poor functionality of these pavements. So what are some of the common issues with the construction of these pavements? Number one, failing to set a uniform subgrade. The subgrade of these pavements need to be perfectly uniform for a better functionality. Number two, failing to place the subgrade at the correct elevation. So the elevation of subgrade matters. Number three, failing to moisturize the subgrade before placing the concrete. And four, insufficient compaction of the subgrade. So if you're involved with the construction of these pavements, you need to care about these four things. You need to watch these four things. Next is the maintenance of these pavements. So they do require maintenance. In terms of maintenance, I should tell that a good maintenance comes from a good design. By that, I mean design should enable access to different parts of the pavement so you can easily maintain it, okay? What are some of the recommended practices to remove dirt, mulch, and other particles? Number one is vacuum sweeping. Some of you, I'm sure, have seen it before. So it can, it can vacuum, it can suck the dust from the surface of the pavement. The effective depth is very limited. I guess it's 1/8 of an inch, so it's not that deep. The second one is pressure washing. Pressure washing is also very impactful, specifically after construction activities, which will create a lot of small particles and sediments to the surface of the pavement, okay? And if the surface of the pavement is killed by sediments, you have lost it. So it's very important. It's like it's not pervious anymore, technically, right? Okay. What are some of the concerns about pervious concrete technology that requires further research? Number one is the gradual decline in permeability and functional deterioration. So, how does it happen? As the voids or the network of voids gets clogged in the course of time, then the permeability, like I said earlier, will be reduced and it won't function the way you would like it to. So the intensity of clogging depends on some factors. If you want to minimize clogging, what factors you need to take into consideration? Number one, what is the location of the pavement? Why that is important? Because it tells you the amount of exposure to clay and small particles. So, the measures you take should depend on the exposure of the pavement to small particles. Number two is the traffic loading, because porous concrete pavement is not that strong with the existing technology for compressive strength. So you should take into consideration how much load is applied on it. And number 3 is the quality of construction of the pervious concrete. So these 3 items will tell you, will actually have an impact on the speed of deterioration or decline in the permeability of these pavements. So let's get some more information about voids clogging. Number 1, clogging material rarely migrate deeper than ½ inch, okay? So if you can manage them on the surface, they will not go deeper based on the studies. Most of them will be, captured on the surface in ½ inch of depth. Number 2, unfortunately, cleaning, like sweeping and vacuuming, can only clean it for 1/8 of an inch, okay? And with the existing knowledge, we need, we need further research to solve that issue. And number 3 is that the cloggings, the clogged materials, in the course of time, they will consolidate and get more firm, and they are harder to control. Number 2, reduction of water storage capacity. As a result of clogging, the water cannot easily move and penetrate or infiltrate into the pavement, and that impacts the water storage capacity of these pavements. We ideally want the porosity of these pavements to be between 15% to 35%. The higher, the better. So another existing limitation or drawback with these pavements is limited frost resistance, because it is connected to clogging, because when clogging happens, water will be captured and will be stored in the pavement for a longer time. If the weather is too cold, the water will freeze there, and due to freeze-thaw impact, it will cause cracks in the pavement. Does that make sense? The factors that affect the freeze-thaw is the amount of coarse aggregates. Studies show that although coarse aggregates are better to increase the permeability, if you use low amounts of fine aggregates, it could have a positive impact on increasing the resistance against freeze-thaw. The percentage given is 5% of fine aggregates will have a positive impact on that. So the low compressive strength is a result of high porosity of these pavements and lower use of mortar content. So it can lead to structural failure, and we need further research to improve the compressive strengths of these pavements. So in the remaining minutes, I present result of my friend's test. So they had a pervious concrete surface and a porous asphalt, and tested it for the amount of outflow or exfiltration. And as you see, this is 100%, and this is coarse aggregate. So it could capture up to 100% of coarse particles. So it is showing that these pavements can effectively control those particles. So the results of his experiment, Ani's experience, are porous asphalt does reduce the stormwater flows with very little runoff coming off the surfaces, and traffic use appeared to be a great driver of infiltration variability. And removal of pollutants was very obvious, particularly for particulate matter. Here are some of the references I used, and I'm now here for questions.